Today we will discuss about a new topic, subset. Let us understand with the help of example. Consider the set X, set of all students in your school, and another set Y, set of all students in your class. So we note that every element of Y is also an element of X. Because of that, set X talk about set of all students in your school, and set Y talk about all students in your class. Is it clear? Suppose in your school there are 500 students in your school, and this is a 500 total number of students, and Y talk about um, in the class 10th or in class 11th. There are 90 students in the class 11. So these 90 students also belong in this chapter, so that Y will be the subset of X. So it is denoted by like that. Y is a subset of S. So this is a basically example of the subset. And we denoted this is with this symbol, this, and this symbol stands for is a subset or it is contained. So we can read like as is a subset. So Y is a subset of X. This we can read as Y is a subset of X. Y is a subset of X. We can read like that. Now this is the definition of the subset. A set A is said to be subset of set B if every element of set A is also an element of set B. Every element of a set A is in the set B, then we can say set A is a subset of set B. In other words, A is a subset of B if every A mean element, A mean element A belongs to set A, and same element also belong to set B. So it is often convenient to use the symbol this. This symbol, this mean implies. We can read this implies. So using this symbol we can write the definition of subset as follows. A is a subset of B. A is a subset of B if element A belongs to a subset A, and is implies element A is also belong to set B. Suppose, let us understand with the help of an example. Suppose A is equal to set 1, 2, 3, and B is equal to set 1, 2, 3, 4, 5, and 6. So 1 belongs in set A, and 1 is also belong in set B. So this is a basic reason behind it. So that's why set A, every element of a set A also present in set B, so that A is a subset of B. Now we read the above statement as A is a subset of B. If A is an element of A, implies that A is also an element of B. So basically this is a representation of a subset. This is a representation of a subset. A is a subset of B. So we can represent, this is the example. And now Here some of also example given. A is a subset of B and B is a subset of A. For this, if condition is given, A is a subset of B and B is a subset of A, so that both set will be always equal. If A is a set of A, B and C and B is a set of B, C, A. So A is an element, small, this is an element of set A. So A is also here and A is also in the set B. B is also the element of set A and B is also the element of set B and C is also element of set A and C is also element of set B. Doesn't matter the position of the element in the set. So these type of set we can say set A is a subset of B and set B is a subset of A. Is it clear? So we can write like that both set A and B are equal, where this sign is a symbol of two-way implications and is usually read as if and only if. This symbol we can read as if and only if, or we in the brief we can read like that. Now it follows from the above definition that every set A is a subset of itself. Whatever set is given in the problem, whatever set you face in your real life, every set is a subset of itself. Now we can represent this statement like that: every set is a subset of itself. Since the empty set phi has no element, we all know about the empty set. Empty set doesn't have any element. So we agree to say that phi is a subset of every set. Phi is a subset of every set. These are two important points which is very helpful to understand some of the problem when we solve related to the subset. And now this is some also important point. Set Q. Q is called a rational number. Is a subset of a real number. Is a subset of a real number. Because of that rational number we can represent like that in the form of P by Q, where Q never is equal to 0. So for example, these 1 by 2, 3 by 5, 7 by 3, so these all are the rational number. All these rational number belongs in a real number. So we can say the rational number is a subset of a real number and we can represent like that. Point number 2, if set A is a set of all divisor of 56 and B the set of all prime number of 56, then B is a subset of A. We can write like that also. B is a subset of A. This is a very easy point, and after that let us discuss with the point 3. Let A is equal to 1, 2, 3, 5 is a set, and set B also a property form of a set. So x such that x is an odd natural number less than 6. Then A is a subset of B and B is a subset of A. Behalf of all these two things, we can say that set A and set B both will be the equal set. Set A contain element 3, 1, 3 and 5, and set B contain element odd natural number less than 6. So odd natural number are also 1, 3 and 5 less than 6. Odd number will be 3. So set A and set B both will be the equal set. And we can also say that set A is a subset of set B and set B also is a subset of A. Now point number 3, set A is a vowel of English alphabet. It contains 5 elements and set B also contains, set B contains 4 elements. Then A is not a subset of B, also B is not a subset of A because all the element of a set A and all the element of set B cannot match each other. No, only element A belongs in set A and A also belongs in set B, but E is not belong to set B and B is not present in set A, so that these two sets are not a subset to each other. Now let A be the two set, A subset of B and A not equal to B, then A is called a proper set. Listen, A is a subset of B and A not equal to B, A not equal to B. Then A is called a proper subset of A and B is called a superset of A. Like as, let us understand with the help of example, set A is equal to 1, 2, 3 is a proper subset of B. B is this set contain 4 elements 1, 2, 3 and 4 and set A contain element 1, 2 and 3. So A is a proper set of B and B is a superset of A because B contain more elements than set A. If a set A has only one element, we can it a singleton set. We call it is a singleton set, thus we can represent like that is a singleton set. If a set has only one element, we call it a singleton set. So basically here we already discussed about the subset, proper set, and superset. And singletons. Singletons. 1, 2, 3 and 4. 4 things we have already discussed here. And now, suppose A is equal to element 1, 2, 3 and set B is equal to element 1, 2, 3, 5, 6. A is a subset of B. Because of that, every element of a set A also present in set B. And we can also say that A is a superset of B. And B is, A is a subset of B, but A also is a proper set of B and B is a superset of A. So basically this is a discussion for today. I hope you all understand about the subset and proper set, superset, singleton set. Thank you so much.